Let's start the exercise 2.2. Find the zeros of the following quadratic polynomials and verify the relationship between the zeros and the quotient. So our first question is x square minus 2x minus 8 is equal to 0. So this is our first equation. So x square minus 2x minus 8 is equal to 0. Multiply the first and constant, first and last term. This will be minus 8 into x squared. Let us find out the factors of 8. So you can write it like 4 into 2. So if you sum these two, you need to get the middle term. Minus 4 plus 2 will be minus 2. You can write this as x square. I'm writing x square minus 4x plus 2x minus 8 is equal to 0. So you have to take common as x. So it will be x minus 4. Take the 2 as common. It will be x minus 4. So in these two, you are seeing x minus 4 and x minus 4 common. So x minus 4 take the common and the remaining will be x plus 2 terms equal to 0. Whereas x minus 4 is also equal to 0 and x plus 2 is also equal to 0. So x can be 4 and x can be minus 2. Let us take these as our zeros. Zeros also called as roots. Zeros also called as roots of this particular equation. Let the roots be, or let the zeros be alpha and beta. So our alpha is 4 and beta is equal to minus 2. Now they are asking us to find out the relationship between the zeros and the coefficients. So it is in the form of, the question is in the form of ax square plus bx plus c is equal to 0. So if you compare this equation with our question, x square minus 2x minus 8 is equal to 0, where our alpha plus beta is equal to, the formula is minus p by a. This is sum of the roots. In sum of the roots, you can find out alpha plus beta. Alpha is 4, beta is minus 2. Minus p by a. Compare these two. B is minus 2, nothing but minus of minus 2 divided by a is 1. So 2 is equal to 2. So verified. This is verified. Next one. Product of the roots alpha into beta. The formula is c by a. Alpha into beta means 4 into minus 2, where c by a. C is minus 8. A is 1. So minus 8 is equal to minus 8. Hence proved. Let us look at the next problem. So the next problem is 4s square minus 4s plus 1. So 4s square minus 4s plus 1 is equal to 0. Multiply the first and last term. 4s into 1 is equal to 4s square. Find out the factors for 4. 2 into 2 you can write. So directly for the middle term, minus 4 is equal to minus 2. Minus 2 will be minus 4. So minus 2 into minus 2 is also equal to plus 4. 4s square minus 2s plus 1 is equal to 0. Let us take common 2s. So the remaining will be 2s minus 1. In this, take the common as 1. In these two, the remaining will be again 2s minus 1. So in both the terms, 2s is common. So to take the 2s as common, 2s minus 1 into 2s minus 1 is equal to 0. 2s minus 1 is equal to 0, and again 2s minus 1 is also equal to 0. S will be 1 by 2. Same thing here also, S will be 1 by 2. Let the zeros be alpha and beta. So here our alpha is equal to 1 by 2. Beta is also equal to 1 by 2. Let us compare the relationship between them. Verify the relationship between the zeros and coefficients. So what is the equation? Ax square plus bx plus c is equal to 0. Compare it with our equation 4s square minus 4s plus 1 is equal to 0. So the sum of the roots alpha plus beta is equal to minus b by a. Alpha is 1 by 2. Beta is also 1 by 2. B is minus 4. So minus into minus 4. A is 4 divided by 4. So 1 by 2 plus 1 by 2 is equal to 1. Half plus half is equal to full 1, which is equal to 4 ones are 4, 4 ones are 4. Minus into minus 1. So 1. 1 is equal to 1, verified. Alpha into beta, product of the roots, is equal to C by A. Alpha is 1 by 2. Beta is also equal to 1 by 2. What is C by A? C is 1 and A is 4. 1 by 4 is equal to 1 by 4. Therefore, the equation is verified. Next question. 6x square minus 3 minus 7x. Let us write it in the order. 6x square minus 7x minus 3 is equal to 0. Let us multiply. 6x square into minus 3 results minus 18x square. You have to write down the minus 18 as minus 7 with the factors. So for this 18, you can write 3 into 4 as your factors, and you have to keep minus symbol for 1. Let us take 3 into minus 4, or else any other factors. 9 into 2 also you can take. So this is not possible. This is not possible. For 9 into 2 it is possible, because minus 9 plus 2 is equal to minus 7. So 9 2s are possible. 6x square minus 9x plus 2x minus 3 is equal to 0. So in these two, we can take common as first one x, next one in 3 table you can take. So the common will be 2x minus 3. So directly 2x minus 3 you can see in the second. Take 1 as common. 2x minus 3 is equal to 0. 3x plus 1, and the common is 2x minus 3 is equal to 0. 3x plus 1 is equal to 0, and also 2x minus 3 is equal to 0. Here x will be minus 1 by 3. Here x will be 3 by 2. Let us take these as our alpha and beta. Alpha is equal to minus 1 by 3 and beta is equal to 3 by 2. Let us check the relation. Compare it with the ax square plus bx plus c is equal to 0. Equation is 6x square minus 7x minus 3 is equal to 0. Sum of the roots alpha plus beta is equal to minus b by a. Our alpha is minus 1 by 3 and beta is 3 by 2. And here minus b by a. Minus b is minus 7. Divided by a is 6. Now minus 2 plus 9 divided by 3 2s are 6, which is equal to minus 7 by 6. So that minus 7 by 6 is equal to minus 7 by 6. So this is proved. Now alpha into beta, whereas product of the roots are c by a. So our c by a is equal to minus 1 by 3 into 3 by 2. 3 divided by 2. 3 got cancelled. One numerator, another one is denominator. C by a. Here our c is minus 3 divided by a is 6. 3 ones are 3 twos are. So minus 1 by 2 is also equal to minus 1 by 2. Product of the roots and sum of the roots both are verified, hence proved. Verification done. Anything you can write. Next question. 4u square plus 8u is equal to 0. So 4u square plus 8u is equal to 0. There is no constant you're seeing, so the constant will be 0. In these two, directly you can take the common because the constant into 4u square is equal to 0 only. No need to verify the, no need to find out the roots for this equation. So directly 4u you can take as common. So u plus 2 remains u plus 2, which is equal to 4u is equal to 0 and u plus 2 is also equal to 0. So u will be 0 and u will be minus 2. So let the zeros be alpha and beta. Alpha is equal to 0 and beta is equal to minus 2. Let us verify the relationship between the zeros and the coefficients. Compare it with the ax square plus bx plus c is equal to 0, whereas 4u square plus 8u plus 0 is equal to 0. A will be 4, b will be 8 and c will be 0. Sum of the roots alpha plus beta is equal to minus b by a. Alpha plus beta, so 0 minus 2 is equal to minus b. Minus 8 divided by 4. Minus 2, 4 ones are 4 twos are. Minus 2 is equal to minus 2. Now, product of the roots alpha into beta is equal to c divided by a. 0 into minus 2 is equal to 0. C is a 0. This is our c. No constant, so keep 0. 0 divided by anything will be 0. 0 is equal to 0. Hence, proved. Both are verified. Are verified. Next question is t square minus 15. T square minus 15 is equal to 0. You can write this as t is equal to t square is equal to 15. If this square goes to right hand side, it will be square root. T is equal to plus or minus square root of 15. So t will be plus 15 square root of plus 15 or t will be minus square root of 15. Now let us compare it with the equation. So you can write alpha is equal to root 15 and beta is equal to minus root 15. You can compare this equation with ax square plus bx plus c is equal to 0. There is no x term, x coefficient and x term, whole term. So you can replace it with a 0. T square plus 0x minus 15. So our b will be 0. A is 1 and c is minus 15. Let us find out the relationship between the zeros and the coefficients. Alpha plus beta is equal to minus b by a. Alpha is root 15, beta is minus root 15, which is equal to minus 0 divided by 1. 0 by anything is 0. 0 is equal to 0. Now product of the roots alpha into beta is equal to c divided by a. Alpha is root 15, beta is minus root 15, which is equal to c is minus 15 divided by 1. Root minus of minus into minus, minus into plus minus. Root 15 into root 15 is equal to root 15 whole square. Square root to cancel is equal to minus 15. Minus 15 is equal to minus 15. So it is verified, hence proved. Next question is 3x square minus x minus 4 is equal to 0. Let us write this equation in order. 3x square, it is already in order. 3x square minus x minus 4 is equal to 0. Minus 3x square into minus 4. is equal to minus 12 x square. Let us find out the roots for minus 12. Directly you can take 3 into minus 4. Why? Because minus 4 plus 3 is equal to minus 1. You need to get minus x only, which is multiplied with the 1. You can write it as 3x square minus 4x plus 3x minus 4 is equal to 0. In these two, take the common as x. So it will be 3x minus 4. Take the 1 as common, directly 3x minus 4 will be remain in this equation, equal to 0. X plus 1 into 3x minus 4 is equal to 0. Whereas x is equal to minus 1 and x is equal to minus 4 4 by 3. 4 divided by 3. Alpha is equal to minus 1 and beta is equal to 4 by 3. Let us find out the relationship between these two. Compare it with the ax square plus bx plus c is equal to 0. I am writing the equation at down. After the formula 3x square minus x minus 4 is equal to 0. Compare these two. Alpha plus beta, sum of the roots is equal to minus b by a. Alpha is minus 1, beta is 4 divided by 3. So minus of b is minus of minus 1 divided by a is 3. Minus 3 plus 4 divided by 3, where 1 divided by 3. So 1 by 3 is equal to 1 by 3. Alpha into beta. Find out the product of the roots is equal to c by a. Alpha is minus 1, beta is 4 by 3. C is equal to minus 4, a is equal to 3. So minus 4 by 3 is equal to minus 4 by 3. Both are verified, hence proved. The next question is second question. Find a quadratic polynomial each with the given numbers as the sum and product of its zeros respectively. So they have given the sum and product of the zeros. Here our sum is 1 by 4 and product is minus 1. Sum of the zeros, if we consider these as alpha and beta, alpha plus beta they have given as 1 by 4. Alpha into beta, product of the zeros given as minus 1. You have to write this as polynomial. So what is the general form for the polynomial? X square minus alpha plus beta into x plus alpha into beta is equal to 0. So x square minus 1 by 4 into x minus 1 is equal to 0. Take the common denominator as 4. So 4x square minus 4x minus x. No need to multiply with the x. So minus x minus 4 is equal to 0. 4x square minus x minus 4 is equal to 0. Next problem is root 2 is sum of the roots. 1 by 3 is product of the roots. Alpha into beta is 1 by 3. General form is x square minus alpha plus beta into x plus alpha into beta is equal to 0. X square minus root 2 into x plus 1 by 3. Take the 3 as common denominator. It will be 3x square minus 3 root 2x plus 1 is equal to 0. You can write it as, if this 3 goes to right hand side, it will be 0. 3x square minus 3 root 2x plus 1 is equal to 0. This is our final quadratic polynomial equation. Next one. Third question. Alpha plus beta is equal to 0. Alpha into beta is root 5. Let us write down the equation x square minus alpha plus beta into x plus alpha beta is equal to 0. So x square minus 0 into x plus root 5 is equal to 0. Directly you can write it as x square plus root 5 is equal to 0. Next question. Alpha plus beta is equal to 1 and alpha into beta is also equal to 1. X square minus alpha plus beta into x plus alpha beta is equal to 0, where x square minus alpha plus beta is 1 into x plus alpha into beta is also equal to 1, equal to 0. X square minus x plus 1 is equal to 0, our final equation. Next question. Alpha plus beta is equal to minus 1 by 4. Alpha into beta is equal to 1 by 4. X square minus alpha plus beta into x plus alpha into beta is equal to 0. X square minus 1 by 4 into x plus 1 by 4 equal to 0. Take the 4 as common denominator so that 4x square plus minus into minus plus x plus 1 is equal to 0. The final polynomial will be 4x square plus x plus 1 is equal to 0. Next question. The last question is alpha plus beta is equal to 4. Alpha into beta is equal to 1. X square minus alpha plus beta into x plus alpha beta is equal to 0. Directly x square minus 4x plus 1 is equal to 0 is our final polynomial. That's it for the exercise 2.2. Let's meet in the next video.